Lesson 32, Phases of Matter and Phase Changes. In this lesson, we have just one objective, and that is to analyze the substance using the properties of its phases of matter. So to start off with, we actually need to have a definition of matter. And the matter that we're going to be taking a look at is anything that has mass and takes up space. For the most part, we could say that it's anything that we can physically touch. We may not want to touch it. For example, you won't want to touch boiling water, but you can touch it. There are 4 phases in which matter occurs: solid, liquid, gas, and plasma. Now, before we actually get into the difference between each of these phases of matter, we need to understand what is meant by a cohesive force. Cohesive forces are forces that hold molecules of the same type together. So for example, when you have a drop of water, the forces that hold all of those water molecules together as a drop would be cohesive forces. But when you have something like a piece of tape stuck to, say, a wall, that's 2 different types of molecules. So that's not cohesive. That's what we call adhesive. So these are the forces that are holding molecules of only the same type together. Now, in a solid, you have very strong cohesive forces. Remember, all molecules are moving because they have internal energy. But in the case of a solid, they're only vibrating. They're not actually moving around. So the cohesive forces in a solid are so strong that the molecules can't really move. They're just vibrating, trying to get away from each other, but they can't. In a liquid, the cohesive forces are strong enough to hold molecules together, but not strong enough to hold them in place. It would be a lot like having a bag full of marbles. The bag holds all the marbles together, and the marbles can move around inside, but they're still held together. In a gas, you have very weak cohesive forces. Usually you need something else to hold the molecules together. For example, a container. Or on the Earth, gravity is much stronger than these cohesive forces and keeps our atmosphere together. So in a gas, you have very weak cohesive forces, usually needing something else to hold the molecules together. The 4th phase of matter is what we call a plasma. And a plasma is something that you may not be familiar with. It has nothing to do with blood. In actuality, it's a gas where the molecules have so much energy. So think of gas molecules bouncing around all over the place. But the molecules have so much energy they lose some electrons and become ions. So now not only do you have these molecules bouncing around all over the place, you have electrons bouncing around all over the place too. And since you have electrons which are moving, you have electricity going on. So because you have these, in essence, ions, because these molecules no longer have all of their electrons, it's usually considered to be a charged gas. Now, this is how you have something like a neon sign. In a neon sign, you have a gas which is charged, which is why it glows. As it turns out, this is the most abundant phase of matter in the universe. And this is because this type of matter is what's in stars. The gas in stars has so much energy that it becomes a plasma. And that's what makes it one of the things that makes it glow. Since stars make up most of the matter in our universe, that's what makes plasma the most abundant phase of matter in our universe. To give you an idea about how much this takes up, the Sun and all of our planets, as well as their moons, the asteroid belt and the Kuiper belt, make up our solar system. If you were to take all the planets, their moons, the asteroid belt and Kuiper belt, and compress them all together, they would make up less than 1% of the mass of the sun. That's how huge the sun is. So most of our mass in the universe is plasma. Now, matter can change from one phase to another in one of two ways. It can either do so by a change in temperature, or by a change in pressure, or both. Now, we are most familiar with temperature changes causing phase changes. So, for example, we heat up some water and it boils, or we put ice in a drink and it melts. So if the temperature changes, the kinetic energy of the molecules change, which affects the cohesive forces of the substance, hence bringing about a phase change. But one way that we're not quite so familiar with, because it doesn't happen every day, is pressure. Large pressure can force molecules together. So, for example, if you were to go to a place like Air Products, which puts gas in containers, and you can come across things like liquid oxygen or liquid nitrogen, they don't just take these gases and put them into a freezer and then they condense. What actually happens is they apply huge amounts of pressure to these gases and force them into being liquids. In the same way, they can force carbon dioxide not only to be a liquid, but to be a solid. And solid carbon dioxide is what we call dry ice. This is also the way that a pressure cooker works. If you've ever used a pressure cooker in a kitchen, you have a top on your pressure cooker which is clamped down. And that huge amount of pressure forces the steam back into being a liquid, water. Weak pressure does the opposite. Weak pressure helps fixed molecules break apart, so things can become other phases much quicker. So when we're talking about pressure changes, and we apply huge amounts of pressure to force something into being another phase, this can only happen to a certain point. That's called the critical point. The critical point is the temperature at which, no matter how much pressure you apply, you cannot force the molecules together. The substance must be a gas. So, as I said, in the case of a pressure cooker, it's forcing the steam molecules together into being a liquid. And the water is now getting hotter than its normal 100 degrees Celsius or 212 degrees Fahrenheit. But after a point, in this case for water, 374 degrees Celsius or 705 degrees Fahrenheit, no matter how much pressure you apply to that steam, you cannot force it together to be a liquid. It must be steam. Now, this actually is a huge amount of pressure, but that's what the critical point is. And it's also because of pressure that a substance can exist in more than one phase at one time. So, if you have a glass of ice water, you actually have water in 3 phases at one time. Because you will have ice cubes, which are solid water, liquid water in the glass, as well as water vapor in the air, because all of our air has some moisture in it. So because of pressure, we have water existing in more than one phase at one time. Now, for your vocabulary, in addition to what you've already gotten, you should know the names of the phase changes, and most of these you will be familiar with from everyday life. The first is going from a solid to a liquid. Think of an ice cube going to water. It's melting. The second one you may not necessarily be familiar with. A solid going directly to a gas. That's called sublimation. That would be like, for example, on a very warm spring day, when you see snow still on the ground, but it's steaming. So it's going right from being solid snow to going to water vapor. So it's going right from being a solid to a gas. Going from a liquid to a gas is called boiling or vaporization. Notice that it's called vaporization and not evaporation. Evaporation actually means to turn to a gas, and evaporation includes both phase changes of sublimation and boiling or vaporization. Going from a liquid to a solid is freezing, like water turning into ice. And going from a gas to a liquid is condensing.